Hello, good day, DSE to Matt. So thank you very much for your kind consideration na naintindihan ninyo na mahina talaga yung internet ko. So ito ay record video lecture or lecture video for our lesson 3 para hindi naman tayo ganong mahuli. And then next week, probably we will have our first long exam. Okay? So thank you very much sa inyong kind consideration and sana magkaroon ako ng internet connection na stable. Sana hindi na rin mag-uulan. Okay. Again, good day and now let us discuss our lesson 3. This is a set of axioms and finite geometries part 2. Okay. So let's start. So, introduction to finite geometries. So, from the standpoint of structure, we all know that Euclidean geometry is complex. The Euclidean plane has an infinite number of points and lines in it, and a rich collection of theorems continues to increase over the years. By contrast, miniature geometries have just a few axioms and theorems, and a definite number of elements that can be named by a counting number. And these geometries are what we call the finite geometries. So in this lesson, we are going to discuss two theorems about the three-point geometry. Okay, so that is the first one kasi yung three-point geometry yung pag-uusapan natin which has two theorems. So later on, ma-encounter natin yung theorem na sinasabi ko. All of the geometry studied in this lesson have a finite number of axioms and a finite number of undefined terms. Thus, those features do not make a geometry finite. Instead, a finite geometry has a finite number of elements, that is, points or lines, or things to work with. So for the geometries, these elements can be considered points and lines. It would seem that finite geometries are thus inherently simpler than geometries with an infinite number of points and lines. Although that may not be your opinion when you first encounter them. So, dito kay finite geometry, more likely we have finite number of points and lines. Unlike sa ibang kinds of geometry which has a lot of number ng points and lines. So, historically, the first finite geometry to be considered was a three-dimensional geometry, each plane of which contained 7 points and 7 lines. The modernity of finite geometries is emphasized by the fact that Fano explored this finite geometry in 1892. So now, who is Fano? Uh, si Fano na ba ang sisisihin natin? That's why we have uh, finite geometry. Okay, so Fano is very famous. So actually, he is Gino Fano. He is very famous for his finite projective planes or also known as Fano plane. So ayun yung parang pinagmulan ng mga theorem ng finite geometries. Next slide. It was not until 1906 that finite projective geometries were studied by Veblen and Bossi. So since that time, a great many finite geometries have been or are being studied. Many sets of points and lines that were already familiar figures in Euclidean geometry were investigated from this new point of view. So, however, at the present time, it is quite possible for a mathematics major to graduate without ever encountering finite geometries. Although it is also true that finite geometries are being used increasingly as enrichment topics like this and extension units at the high school level. So I I don't know if you already encountered this kind of finite geometries during your senior high school? Kasi hindi naman ako nakaranas ng senior high school. So, finite geometries also find a practical application in statistics. All of the finite geometries in this lesson have point and line as undefined terms. The connotation of line is not the same in infinite geometry as in ordinary Euclidean geometry. However, since a line in finite geometry cannot have an infinite number of points in it. Again, sabi natin, a line has an infinite number of points. Pero dito kay finite geometries, we only have a finite number of points in a line. So the first simple finite geometry to be investigated called a three-point geometry. It has only four axioms. Sabi ko nga kanina, we are going to talk about the axioms for three-point geometry. So first, okay, let me highlight it one by one. First, there exists exactly three distinct points in the geometry. So that is the first axiom. Sabi daw po, sa geometry, we only have three distinct points. The two distinct points are on exactly on line. Okay, let's say for example, let's have three distinct points. And then that is the first axiom. The second axiom, we have two distinct points are on exactly one line. Let's have one, 2 points, and then let me draw a line in here. Uh, Let me just make it small. Okay. Hindi man siya pantay. Ayan. So, exactly 2 points within a line. And then the third axiom we have is that not at all points of geometry are on the same line. Hindi daw lahat ng points ng geometry are nasa iisang line. Yes, that is true. And then lastly, two distinct lines are on at least one point. So let's say for example, let's have 2 points. Okay, let's have 3 points. So let's have 1, 2, 3 points. And then let us put lines. So let's say let's have a line in here, hindi pantay again. Okay, let's have a line here, a line here, and a line in here. Sabi dun sa fourth axiom, two distinct lines are on at least one point. So we have here two distinct lines. This line, let us name it as line X, and this one is line Y, and this one is line Z. Let's say, for example, let's look at line X and line Y. They are on the same point, which is this, right? So, meron tayong dalawang distinct lines which lies on at least one point. Okay, so these are the four axioms ng three-point geometry. Remember this. Okay? So not all of this like these figures are actually finite geometry, okay? But it is actually a three-point geometry. So the finite geometry of 3 points can be represented by many drawings, four of which are shown in this figure. Okay, so verify the fact that all four axioms hold for each figure. Okay, so kanina pinakita ko yung ganitong figure, the first figure. So we had the first figure which we had a triangle. This one is also a triangle, and then this one is a circular. So it really looks like a circle or an oval. And then this is the last figure. Okay, but we only have 3 points here, right? As long as the points are three, it can be called as a three-point geometry. Any distinct points po. So while the set of points and lines are such that all the axioms of the three-point geometry hold, there is still the possibility that the geometry might have additional lines not shown, right? So this matter is settled by proving two theorems. First, a comparison of the wording of axioms 2 and 4 leads to the need to determine whether two distinct lines might be on more than one point. So we are not aware kung sa geometry ba ay may iba pang lines that is existing with these figures. Now we are going to prove two theorems again. Sabi ko nga kanina, we are going to encounter two theorems in this lesson. Now let's talk about theorem 1. Okay, so this is theorem 1.1. It says here that two distinct lines are on exactly one point. This is axiom number 2. Now, how to prove this one? So by axiom 4, we will use axiom 4. Sabi doon, two distinct lines are on at least one point, right? So two distinct lines are on at least one point. Let us assume that two lines are on more than one point. We will assume that two lines are on more than one point. Bakit po naging ganon? Sabi po dun sa action 4, there are two distinct lines at least on one point. Pero nung nag-assumption tayo, sabi dyan more than one point. So, we will use the indirect method of proving in here. So, if two distinct lines, L, line L, and line M lies on point P and Q, the action 2 is contradicted. So let's say, for example, let's have a point P here. We have point P and point Q. And then now, let's have two distinct lines. This is line L, and then this is line M. Okay, so the action is actually contradicted. Sabi daw kasi, two distinct lines are on more than one point. Now, we have we have 2 points in here which are P and Q. Let's say for example, si letter P dito and then si letter Q. We have two distinct lines because P and Q would be on 2 points, right? Okay, so theorem 1.1 is proved by what is called, sabi ko nga, the indirect method of proving or indirect argument. The theorem can be written, rewritten in the form of an implication. We are implying into if two lines are distinct, they are on exactly one point. The assumption was made that the conclusion was not true, and a contradiction was reached, showing that the negative assumption was not tenable. So, thus, the conclusion is valid, and by the deduction theorem, Theorem 1.1 is established. So indirect proofs which are probably more effective in geometry rather than in algebra will be used many times in this lesson. So more likely dapat marunong tayo mag-indirect argument or indirect proof. Kasi kay indirect proof, meron tayong assumption, pero yung conclusion natin, na implication, kinuha natin yung negative part nun. Let's say, for example, uh, the conclusion that we have is there there is only one line. Pero, ang assumption natin na i-imply natin is yung negative nun. Let's say, for example, that is letter Q. More likely kasi yung conclusion is actually letter Q yung ginagamit. Now, in indirect method, we will use not Q or the negation of Q, which is yung kabaligtaran ng ating conclusion. That will be our assumption. So the exact number of lines in three-point geometry can now be determined with the proof that we had earlier. Okay, now let's have a theorem 1.2. The three-point geometry has exactly three lines. Okay, so yun yung isa nating ipoprove ngayon. So from axiom 2, each pair of points is on exactly one line. Again, each pair ng ating points lies exactly on one line. Okay? Let's assume that the line is straight. So each possible pair of points is on a distinct line. So the geometry has at least three lines. Suppose there is a fourth line. Okay, let's say for example, we have three lines with two distinct pair. Gamitin ulit natin yung triangle na mukhang letter A. Ayan. So, from axiom 1, sabi doon, there are only 3 points in the geometry. And then we are going to assume that there is a fourth line. So, this fourth line must also be on two of the 3 points. But this contradicts axiom 2 and theorem 1.1, which says that two distinct lines are on exactly one point, right? So the theorem is already proven that there can be no more than three lines in geometry. Okay, so while point and line have been used as the undefined terms in this first finite geometry, other words could be substituted to give an equally meaningful interpretation of the structure. Okay? So in the finite geometry, there are a lot of considerations. Okay, so now let's give an example. So tree. Let's say for example we have a tree. It can be substituted for point and row for line. Tree yung point and then row yung line. So that the postulates would be read as follows. So there exists exactly three distinct trees. Two distinct trees are on exactly one row. Not all the trees are on the same row, and two distinct rows have at least one tree in common. So other interpretations could be found by using pairs of words such as beads and wires, students and committees, or books and libraries. So we can substitute the following words, yung point and line, with some other words which are actually related to one another para ma-figure out ninyo, ma-imagine ninyo, how does this point and line looks like? Okay, let's say for example, we have here a tree. Tree. Tapos row yung line. Sabi dun sa first action, merong tatlong distinct trees. Tatlong distinct trees. Sabi, the two distinct trees are on exactly one row. So, we already have two trees, and then not all the trees are on the same row. Kung dalawa yung distinct trees na nasa isang row, nasa yung isang tree. So, nandito sa taas. Fourth axiom, two distinct rows have at least one tree in common. So this is the first row and this is the second row, which we have one tree in common point, right? Kagaya nga nung triangle kanina, isang line, dito yung isang point, dito yung isang point, dito yung isang point, and then they are connected. That is just the same, okay? So in the finite geometry under consideration, it should be evident from an examination of the axioms and the figure that such Euclidean concepts as length of a segment, measure of an angle, and area. In fact, all concepts concerning measurement no longer apply. In this geometry, if a triangle is defined as three distinct lines meeting by pairs in three distinct points not all collinear, then one and only one triangle exists. The concept of parallel lines does not apply if parallel lines are defined as two lines with no points in common, since each two lines meet in one point. The familiar ideas of congruence also have no meaning in this geometry, even though you are far more familiar with Euclidean geometry than with finite geometry. This consideration of Euclidean geometry is actually a properties that hold in a new geometry will nevertheless give added meaning to the familiar concepts. So the introduction of more significant finite geometries in the next lesson will provide additional opportunities for the same kind of consideration. And that is the end of our lesson. So more likely, theorems lang tayo and axioms. Wala pang ganong kabigat na gawain kasi more on introduction, more on theorems, more on proving lang po. Okay, so now I will post activity number 3 on our LMS, and you will submit that on Tuesday, which is October 20 sa LMS din po natin. Okay? So I hope that everyone is doing well. Lagi pong mag-ingat and magstay lang po sa bahay. So thank you very much and God bless everyone.